Hi, you guys. So here's what we got going on. Let's say you get out of college and your starting salary is $76,000 and they give you a 3.75% raise per year. So what are you going to make after your first year? What are you going to make in the year after? What are you going to make in your 25th year? So if I asked you, let me just annotate this. Okay. So if I asked you, like, what are you going to make after your first year? So let's imagine that year zero is your 76,000. Okay. Now, in year one, I hope you're saying it's going to be 76,000 plus 3.75% of that, okay, times 0.0375, okay? And that should give you, I need a calculator because I don't have one sitting right in front of me. So I have times, okay, is 78,850. You should verify that, okay? Now, what you guys should do is hit pause and do year two because you're taking your new amount, right? And you are actually finding out what you're going to make in your second year. So it should be 78,850 plus 78,850 times 0.0375, right? So if I multiply that, you should have 81,806.88. You should round that up because you are totally worth it. So year three, I hope you're saying, I'm going to take 81,000, blah, 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 and add yada, 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 right? But what if I'm like, let's keep going until we hit year 25? You're like, oh boy. Does anybody have any idea on what they would do? Well, let's go back up here. I'm going to change my color. I'm going to change my color to green. And if you look at this guy right here, okay, these are two terms. And if you look at them technically, if you factor out a 76,000, this winds up being 1 plus 0.0375, right? So therefore, and if I add these two together, this is just 1.0375. So if you look over here, in order for me to have gotten 78,850, I did 76,000 times 1.0375, okay? Now, if you come down here into year two, I hope you're saying to yourself, oh, I could do 78,850 and then multiply that by 1.0375. There should be a little 7 in there, okay? Now, which is what this is equal to, right? I got this by doing 78,850 times that, and it gave me this, right? So this right here is the same thing as 78,850 times 1.0375, right? But here's what I want you to do. I want you to, I'm going to change the color again. This number here, how did we get that number? And if you want to, maybe hit pause and go find out. How did I get 78,000, which was this guy right over here? I hope you said, oh, it's that. So now what you can physically do now is you could take this and replace it with this. So now we have 76,000, right, times 1.0375 times 1.0375, and I hope you're saying to yourself, oh, this is the same thing as 76,000 times 1.0375 squared. Isn't that interesting, right? So if I said to you, I wanted year three, because this is year two, you do 76,000 times 1.0375 squared. If I said year three, I hope you're saying, ooh, 76,000 times 1.0375 cubed. So now if I go to year 25, which is what I asked you up here, if you want to hit pause, go find out. Oh, I'm in the dark. I'm in this classroom. You ever do, look at this, I'm swinging my arms. There we go. Okay, and we want to do year 25. Hit pause and go do it yourself, but if you're going to be that person, I hope you're saying to yourself, it's 76,000 times 1.0375 to the 25th power, right? And you should find out what that is, 76,000 times 1.0375 to the 25th power. So after 25 years, you're making over you're making almost $191,000. So this is about 190,772 and 70 cents. So after 25 years with the company with a 3.75% raise every year, after 25 years you'll be making almost 191,000, which is pretty good. So if I said to you, what are you making in the teeth year? Okay, if I said to you, let's make a pretty little equation, you should basically be telling yourself it's going to be y equals 76,000 times 1.0375 to the t power. And that right there is the function that we're talking about. Now I got a question for you. What kind of a function is this? I hope you said exponential because that's exactly what it is. Now, what we want to do is we're going to go and graph this thing, and if you ask yourself, what does an exponential function look like? I hope you realize an exponential function is like, woo-hoo-hoo, where it goes off into the sunset. This is how we want our money to grow, and we will talk more about this when I actually see you guys. So the first thing we're going to do is we're going to go into our calculators, okay? So go into your calculator. And this is where I got to take over with my little keypad. And I'm going to go into y equals. And we're going to clear what I have here out. And we're going to type this function in, which is 76,003. And then times 1.0375 raised to the x power. Now, when we go into our window, because we always want to know, by the way, the minimum amount of money you're going to make is how much? I hope you said 76,000, right? Now, how much did you make after 25 years? It was close to 191,000, but I have to tell you guys a little story. You're not going to end your career, you're not going to be finished working after 25 years because you're going to be too young. You're going to be like 47 or 48. So technically you're going to be working for probably about 40 years. So when you go into your window, okay, when you go into your window, you'll notice I already have some things set up because we did a problem earlier in the other class. So over here, X is your minimum time, so that's year 0 when you first started. So let's say hypothetically you work for 43 years, okay? So that's the maximum time you're going to work. And our minimum is 76,000, right? Because that's what our minimum salary is. That's what you started with. Now, if you work for over 40-something years, I'm going to suspect that you need to guess a good amount on what your salary would probably be then, especially since it's growing exponentially. And if you said maybe 600 or 700,000, 100, 1, 2, 3, right? Then you can go ahead and press your little zoom 0 key, and this is exactly how your money is growing. So this is basically your salary. So if I hit my trace key, right, that means after 21.5 years, you are making $167,000, or almost $168,000. So as you keep going along here, this is basically telling you how much money you're making along that trek there, okay? So one thing that we could do is, if I said to you, let's find out when you're going to make 230,000, okay? So if you want to find out when you're going to make 230,000, you type in 230,000 into y2, because that's going to be a horizontal line and it's going to intersect your graph there. So if we find that point of intersection, second calculate intersect, okay, which is 5, I'm going to use my up arrow key because it's going to get me closer there if I go to the horizontal line. And I have to wait because this thing, you know, my thing goes crazy. I pressed a lot, so I'm just going to wait. Okay, a couple more, couple more, couple more, couple more, couple more, couple more. Yours is so much faster than mine. This is so annoying. Okay. Yeah. All right, so the intersection is basically telling me this. If you look at this, in what year will you make $230,000? I hope you're looking at the x-coordinate and saying to yourself 30 years. Now, there's an algebraic way to do this. So what we're going to do is I'm going to take you back here to my workspace, and we're going to actually go ahead and do that. I'm going to show you, and you're going to use your calculator. I'll show you how to use it on your calculator. So we know that y is equal to, right, so I'm going to annotate this, and I have to click onto my workspace. I know that y is equal to 76,000, right, times 1.0375 to the t power, right? Okay. So now I want to know when I'm going to make 230,000. So that's when y coordinate is 230,000 because it's saying t comma 230,000, right? I want to know what t is at that time. So I plug 230,000 into my calculator, or into my equation actually, and I have 76,000 times 1.0375 to the t power, okay? So I hope you're saying to yourselves, the first thing you're going to do is divide both sides by 76,000, right? 76,000 divide by 76,000. And then these three cancel. So I wind up with 230 over 76. I don't care about simplifying that because I'm bringing my calculator into the picture, okay, to the t power. Now, this is an exponential function. So to undo exponential functions, I like to use a natural log. There's a natural log key on your calculator. I'm going to take the natural log of both sides, okay? All right, and what that does is over here, I'm still left with the natural log of 230 over 76 in parentheses, okay, equals. Now, the natural log of this, if you remember your natural log properties, okay, what happens is according to the natural log property, I can take this and bring it down to the front. So this is equal to t times the natural log of a. All right? So over here, this just becomes t times the natural log of 1.0375. Okay? And if I want to solve for t, I'm going to divide by this guy right here. So t is equal to the natural log of 230 over 76, that's all in parentheses there, divided by the natural log of 1.0375. You guys might use log base 10 where it's log. It doesn't really matter. So let's go into our calculator, okay? And if we go into our calculator, now remember, you guys, we found it graphically that it's going to take 30 years for us to do that, but we're going to actually confirm it algebraically, okay? So I do believe that, I'm now doing this from memory, this is unbelievable. Okay, it's going to be the natural log, which is right here, okay? The natural log of 230 divided by 76, close that out, divided by the natural log of 1.0375, close that sucker out, and I'm going to tell you it's going to be 30.0 something. Come on, enter, come on, enter. There it is. So it's 30.08, whatever, 3, blah, 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 blah. But it's basically telling us that it's going to be 30 years, and this is how you would algebraically confirm it, okay? So you guys are getting a worksheet, and you're also getting stuff from the textbook to work on, and I really hope that this has helped you. And if you want to, graph your functions on your calculators and mess around with it, but this is a really nice start and review for exponential functions, because what we're going to be doing is once we have a better understanding of exponential functions, we're going to find out their derivatives, because we want to know if your things are growing exponentially, we want to know how fast that's going to happen. See you soon.